A friend of mine got this Myford ML10 lathe, and he wants to put a quick change tool post on it. And this post was available through Amazon. It said that it was compatible and it does fit the stud, but it's got two problems. The first is that the hold down on it hits and interferes with that. That's problem number one. And problem number two is that the tool bit is too high. You should be able to see that the bit is way above center there. So there's two problems that I'm going to work on. And we'll go back to my shop and I'll show you how we're going to fix it. My name is Steve. Welcome back to my shop. In this video, I'm going to be working on a tool holder setup for a Myford 10 lathe. A friend of mine called me in and he had a Myford 10. The Myford 7 is a pretty popular one, particularly in Great Britain. I don't understand why a Myford 10 is smaller than a Myford 7. I have no idea what the nomenclature means. This is equivalent to about an Atlas or Craftsman, what we call a 618 or a 6" by 18 lathe. Anyway, he wanted to put a quick change tool post on it, and he called me and asked me if I could find something for him. And so I took my quick change tool post over that I made up for my 618, and it would work fine, except that the stud on the cross slide is too large for the hole that's in the quick change tool post. So the first thing that I needed to deal with was to try and find something that would fit that. I'm going to bring you around and show you the tool post, the original cross slide, or actually the compound slide, and I'll show you the tool post that he ended up finding, and I'll show you what the problem is. So here is the Myford compound slide, and the stud on it measures, actually it measures 7/16, and my friend went on to Amazon. He found a quick change tool holder that said it would fit the Myford 10 and the Myford 7, and in fact it does fit over the stud. However, the first problem is that the hold down for the tool post, you'll see, is too large in diameter, and it hits the cam lock lever for the tool post. So that's problem number one. That is the issue that we're going to deal with in this video. The other problem is that this is the tool holder, and when I put in a 10mm shank tool, which is what he got, I'm not sure if you can see it in the introductory video that I showed. It's above the center of the piece that you want to turn. Now that piece of stock that's in the lathe is about 1/4 of an inch, so you can see that it's about 1/8 of an inch too high. So that being said, I started doing some research on it, and I found that a couple of videos where they actually took 3mm off the top of the compound slide. I really don't want to do that. I absolutely can do it, but I would rather, if you look, you can see, and I marked it, I don't know whether you can see the score mark or not, but I can take the 3mm off the bottom of that tool holder, and that'll get me where I want to go, and that way I don't have to modify the original compound slide. And that will be done probably in the second part of this video. So let's get started. I just changed my lighting around. Hopefully you can see things a little better now. So the first thing that I needed to determine was the thread count for this stud, and it turns out that this is a 7/16 BSF, which is a 7/16 by 18 thread. I don't have a tap for that, which is the threading on this, so I ordered a tap in, and I just got that in this past week, so we're ready to go. The next thing that we have to do is to determine how tall the new post has got to be, and it looks like 3/4 of an inch spacer will do that. Now I'm sure you're saying, well, why don't you just make a 3/4 inch spacer and you can use the original lock? Well, I could do that. The problem is that the threads in this piece on the bottom are not in that great a shape, and the thread engagement with a spacer in there I don't feel would be sufficient. I'm going to make a one-piece unit that will I'll be able to thread a larger portion of it to replace this. Now the next thing that I need to determine is how large in diameter I can go, and I can go out to about 825. I think I'm going to shoot for 825. And I have this piece of stress proof, which is one of my favorite materials to work with, and I'm going to see if I can find that part inside of this piece of steel. First thing I'm going to do is face off the end. Got to change the tip, it's broken. The first thing I'm going to do is take and just score a line at 3/4. give myself a stopping spot. Okay, my final cut should be 15,000. Okay, I'm at 727. That should do just fine. Change my tool bit and chamfer the edges. I'll bring you back. Okay, I'm going to drill a 1/4-inch pilot hole first. I started drilling with a stubby length drill, and it's not long enough, so I've just swapped it out for a jobber length drill. I'm going to swap it over to a 3/8 drill, which is the tap drill size for the 7/16 18 BSF tap. Now, somewhere along the line, the battery on my camera went dead, so I drilled the 3/8 hole, which is the tap drill size for the 7/16 BSF thread. Now what I'm going to do is drill it just one size over 7/16 for about the first inch, because I'm not going to attempt to thread the whole thing, and I will have threads for at least a 1/2 inch or better. So I'm putting a 29/64 drill in now, which will give me clearance. And I'm going to drill it about 1 inch deep. Okay, I took the piece out and I took it over to the tool holder and determined how much I needed to cut off the top. And what I want to do is replicate the same piece that's on the top of the original Myford lathe. And so I've marked that off. I'm going to face off the end down to the correct length. Okay, I set my compound slide at an angle so that I can replicate the angle that was on the top of the original nut. Let's give that a try. I think I need to go a little bit steeper angle. Okay, I like that. That should be fine. Alright, let's get the tap out and tap the hole. Okay, I did a countersink on it. Just gonna hit that with the file and knock the burr off. Okay, let's take it over to the bench and see if it fits. So that fits on there pretty well. Actually locks it right up. But my next step is going to be to drill it and thread it for the handle, and I'm going to use the original handle. It's a 5/16 18 thread. So I'm going to set it up in the mill and drill the tap drill size for it. Yeah, I matched up my angle blocks, and this 20-degree angle block takes and works out just about right. That puts the puts it upright. So let's put this in the right direction. Okay. Okay. Okay, I've got my 1/4-inch end mill in place. Just cut it down. That should do it. I'll swap over. It's an F letter drill for the tap drill for the 5/16 18. I do not have a speed controller reverse set up on this mill, so I'm just going to start the tap under power and then I'll finish it off by hand. I just want to get it started straight. Okay. Okay, that should do it. All right, I'll meet you over at the bench. I'm going to use my Noga deburring tool just to clean that up a little bit. Well, 180 degrees out from where I wanted to be. I don't know how that happened. But there is a solution to that problem. Let's try. Alright, I'm just going to put this back in the lathe and take a little bit off of the end, a little bit at a time, until I get the handle stopping where I want it to. Well, there it is. I just took about 10 thousandths or so off of the spacer off the end, and it tightens up exactly where I want it to. So let's wrap this up. Well, that wraps up the first part of this video. I'm pretty happy with the way it turned out. Had a few issues, a few problems along the way. A lot had to do with the fact that I have not been doing a lot of work out in the shop, and I just got to get back in touch with things. But anyway, the second part we will be dealing with the lathe tool height issue. I want to thank everybody for watching this video, and please don't forget to like, comment, and subscribe. See you in the next video.